Hello, welcome on this tutorial on how to use PandaPower to solve a simple network example. So I'm going to take a look at the example that we have in the PandaPower website. So before we go into our Python code, let's just draw like a simple one line out of this. So the system we're going to model is a two-bus system. We have two buses, transmission line between the buses, a load at the end of bus number 2, and then for bus number 1 right here I have like a generator. So it's classical representation of this of models, right? But you will see on this specific example, once we do the code, that this is gonna be represented as an external grid. But for now, but I'm gonna get into that later. But for now, this is just a visual representation. So if we go to our Python, the first thing we want to do, of course, is to import PandaPower. So we're going to import PandaPower, and then I'm just going to call it a PP so I don't have to write PandaPower all of the time. So we have to create first an object, right? So an empty network. Right here we don't have any mandatory parameters. We only have two optional parameters like the nominal frequency, name, and then apparent power in per unit. So what we have right here is like PandaPower, and then for a net, and then create an empty network, right? So create like an object that's gonna store the network and all the sub objects inside of it. So again, very common Python way to do this is just like create an object, and then from our library nickname, and then calling the function create empty network. So here, populator, and then it should be fine. So next, I'm gonna start with the buses. So we're gonna do it like the way we do in Power World. We're gonna start with the buses. So B1, again, an object, you can name it whatever you want. So for buses, if we go here, bus have two mandatory inputs and some optionals. So the mandatory inputs are the network that it's going to be connected to, the element, and the nominal voltage. So we're just going to do the mandatory inputs. We're not going to bother with the optional ones for now. So bus number 1, again, create bus. Yes, it's already here. You also have create bus DC, buses DC, but for now, create bus. Connect to the network object, and then our nominal voltage in kilovolts is going to be 20, right? So same thing for bus number 2. How you do it in Power World, right? It's just start with your buses, and then I think we're going to move on to the transmission line. So let's go to the transmission line for a quick second. So from our line object, we have 5 mandatory parameters. So we have to include the network, the bus that it's gonna start from, and the bus that it's gonna end in, the length in kilometers, and then the standard line type. So we have predefined or customized. You can also create it just like how we do in, for example, in OpenDSS and softwares like that. But for now, I'm just gonna copy what they have in this example. There's gonna be more documentation into this and maybe further projects. But for now, let's just create this line. So again, I mean, you can even create like a line object if you want to, but for now, I mean, I'm just gonna create it, right, just to keep it consistent. Create line, okay, and then again it was network, and then from bus it's gonna be equal B1, right? And even VS Code, you can see how it starts to pre-populate for you, like guide you, and then to bus, right? It's gonna be bus number 2, and then the length in kilometers, let's just say 2.5, which is what they have, and then standard type, it's gonna be, and then for this one, because it's a string and I don't feel very comfortable typing a lot of stuff most of the time, I'm just gonna attach this type. Okay. Finally, we're gonna do the load. Do the load right at the end of bus number 2. So let's go to load. Yes, load. We have 2 mandatory inputs: network that it's gonna be connected to, and the bus that it's connected to. We have other options like the real power of the load, the reactive power, and other optional parameters. But for now, just gonna create it as load, and then create load attach network 2. So it's gonna be bus number 2, and then the actual it's gonna be this. Okay, so I'm gonna use a simple case of power flow. We go here, we have optimal power flow, DC power flow, so diagnostic function. So let's click on this one, right? So you even created a case file, and then you have your results from PyPower, and then you can extract those results. So the input is gonna be a network, and then you can select the algorithm, right? So you can do Newton-Raphson with his multiplier, the backward forward, Gauss-Seidel, or fast decoupled, fast DC decoupled, and also like the voltage angle. You have all this optional documentation. For now, I mean, I'm just gonna go with the default, and you know what? Let's go with Gauss-Seidel. It's one of my go-to algorithms. Algorithm. Hopefully I spell it right. I'm gonna say Gauss-Seidel. Should be pretty straightforward. So for our results, I mean, from our network results bus, we're gonna do the unit, right? Voltages, and let's say that we do from our results file, from the line, let's say the loading percent, and hopefully we get it all right. So delete this terminal, start from scratch. Hopefully I don't get any errors. It's gonna take a little bit to run. Didn't run it very often. So what did I do? No reference bus is available. Okay, so give me 1 second and then I'll be right back. Okay, now you know what, I got a little bit ahead of myself. So before I delete this, so no reference bus is available, so there's no slack bus. I think I got ahead of myself and I didn't go for this generator. We didn't take a deeper look into it, but basically for this case, like a load can represent a generator. If we go to, let's say here, loads again, active power, it can be generation if it's a negative value. You also have the external grid parameters. So if we go to, let me just type it in. So external grid represents a higher level power grid connection, and our model as a slack bus. So just how in Power World, this is gonna be my slack bus at generation. And you can connect it as a higher level power grid connection. It's gonna model the slack. So before we can be here after line, it's fine. We can just say slack pp create external grid, and then if we look at the external grid, your mandatory parameters are the network that it belongs to, as well as the where the slack bus is connected. So network, and then the slack bus is gonna be bus 1 in this case, right? So let's see, save it, let's run it again. We hope that it works. This takes a little bit of time, but hopefully we get good results. Yes, okay. So from our results, so if we start over here, these are the per unit voltages of our buses. So here, like, this is like some programs have like 0 index. So 0 means like the first. So bus 1 has a 1 per unit voltage, and then the load is like almost a perfect power factor, but in this case like 0.99. And then our loading percentage of the line is like a 20%, and there's more results that you can obtain over here, but this library is very useful. So in my experience, I, for example, have used OpenDSS, which is another open source, but it's an external software. Now, I think Pablo Radas, if I'm not mistaken, has created a Python, very useful Python interface between OpenDSS and Python. But what I like about PandaPower is just like another library. You don't have to go outside. So it's based on your preference. I'm barely starting to learn this new package, but this was the first model. So what we have done so far is this model, created here this code, and then solve for the per unit voltage as well as loading percentage. There's so much more you can do. There's gonna be videos, but I hope you liked it and it gave you a good intro to PandaPower using Python.